Thanks everyone for coming. I know it's the last talk of the day, so we'll make this relatively quick. My talk today will be on the learnings and challenges with competitive programming in Python, with a focus on the tertiary and high school contests that people can do. At the moment, I'm a master's student at the University of Canterbury after finishing my bachelor's in computer science last year. Part-time, you'll find me at the Catalyst office, being a full-stack developer on open source projects. And throughout the many weeks of university, I'll be a competitive programmer. Now, part of this experience comes from the New Zealand Programming Contest, where I managed to win it in 2022 and last week in 2024. I competed in the international contest last year, having the privilege of being on the University of Canterbury team to travel to Sydney to compete in regionals. And more importantly than all of that, I was the winner of race condition last night. Now, competitive programming can mean many things. It could be one of those hackathons where you send 8 people from your office to do something that there's no real coding or hacking involved. It could be a test as to who can write the best code. Is it readable, maintainable? It could be something like an exam where you get tested on how well you know a certain language. If you've done LeetCode before or similar like input-output problems, it could be something like that. Or it could be similar to race condition last night, where it's kind of a single elimination contest and it's whoever can survive the longest wins overall. Competitive programming in these contests is a combination of all of them. You've got 3 people around one computer, and the goal is to solve as many problems as you can in 5 hours. You'll usually get about maybe 10 to 12 problems to choose from, and these problems will have a kind of input-output question-answer format, and we'll look at one soon. The winner is the team that solves the most problems. If multiple teams have solved the same number, it goes into who solved those problems the fastest. So there's 2 things to keep an eye on there. You want to be solving the most, but you also want to be solving them fast. And that kind of goes into the languages that you're allowed to do. It's really popular for C++, Java, and Python to be used in these contests, and you just upload a file. Python's really popular in kind of high school and domestic competitions, whereas if you look at the world finals, 99% of those submissions are in C++, and we'll discuss why that's the case. Looking at an example problem, this is from a high school contest last year. We've got a computer that wants to play a game, and it's going to guess a number, and we just have to output a certain string depending on how it relates to the number 5. We get given a clear description of input and output, such as we get given an integer number, and we must output these exact strings depending on how it relates to 5. We also may get given a number of test cases. In this case, we're given 6. And since 6 is higher than 5, we output too high. An example Python solution will look kind of like this. And submitting a file with this would pass the problem, and you'd get points for getting it correct. However, not all problems are this simple. A problem from last year's contest involved Scooby-Doo and Shaggy, and they're in some corners of the room, and you need to find the minimum total distance that they would have to run to reach each other for all pairs of corners. There was another complex one involving brackets and gems and values and pairs, and they get very complex very quickly. It often can take 5 to 10 minutes to even understand what the problem is asking. But what's kind of the difference between the easy problems and the hard ones? The easy problems really test your knowledge of language. For the Python context, do you know what a for loop is? Can you compare 2 numbers? Basic things like dictionaries and even maybe basic libraries like math. The hard problems already assume you're familiar with the language, and so will instead test your knowledge of algorithms. Things like BFS, heap queues, priority queues, dynamic programming, big O complexity, graph theory. You may not have heard of these for a while, but they're essential to be able to solve these hard problems. And that's mainly because of the time limit that's constricted on these problems. Looking back at the Scooby-Doo one from before, it's got a time limit of 10 seconds. What that means is for each test case, your code has to run, complete, and provide an output within 10 seconds. If it doesn't do so in that time limit, it's a fail and you won't get any points for that problem. Normally, this wouldn't be an issue. However, the inputs that they give you for these problems are so large that it makes it difficult to write an efficient script that finishes in that time. The inputs for this problem in particular involve 200 corners in which you've got to do each pair, so that's about 40,000, and the inputs are in ranges of 10 to the power of 6. Multiplying them all together makes about 10 to the power of 14, which would be very difficult to iterate over in 10 seconds in Python. And that kind of boils down to the reason that Python is limiting in these contests. It's slow. So here's a graph that shows how long it takes to calculate pi using some formula about 10 million times. The faster ones here on the left are C and C++, and they're about 100 milliseconds there. The more medium ones are about Zig and Go. They're quite similar to C. And then we also have Java there in red, and that's about twice as slow as C++. And that's why out of those two, C++ is mainly preferred. Now, if we add Python to this graph, you'll see that it's a lot slower than all the other languages. It's about 7 times slower than C++ and 3 times slower than Java. And this is also using the PyPy version of Python instead of CPython, which is the ones that they use for these contests. Because Python is so slow, it's even stated in the problem set that a problem may be guaranteed to have a solution in C++ and Java, but it may not be the case for Python. It could be likely that if you're doing a hard problem in Python, you would be the first person to ever finish that problem in Python. So that kind of raises the question about why should you ever use Python in these contests? It seems like it would be limiting and you may not be able to solve as many problems. Well, there's kind of 2 main benefits. The first one is that you can code very quickly. If we look at just how to print hello world in Python, we use the print function and we put in hello world. It's about as simple as it can get. The C++ solution already adds a bit of complexity. We have to declare a function, we've got to take in some inputs and return something. Okay, but this is never going to be in an actual contest, so we've got another Python line here which gets the median of some numbers that we're passing in some input. The C++ solution is even more verbose. This time we've got to declare a vector and also import it, iterate over some inputs, sort them, and calculate the median. C++ will just get exponentially longer and longer, and it increases the maybe spaces where you can make an error if you're coding incorrectly. Because Python, you can code more succinctly, there's less chance of you to make a mistake, and it may be easier to debug and code and upload it in a shorter number of time. And that also goes us to the next point, in that you don't need to make code readable. If you're just rushing through, you don't need to add comments, have long variable names, or any of that, because you can just submit the file and never ever look at it again. It's not like a professional industry production deployment where you actually have to care about people looking at your code. Here is an example from a submission from a contest last year. Now, this does seem a little bit complex looking at it like this. If we'll just split it up and go from top to bottom, we're getting the input from the user, and then we're going to split it into a list of strings. Because they come in as strings, we need to map them to an integer, and then we're going to take the sum. And now the trick here is that on the right, we're going to check if the modulo of it equals to 0. Now this will just return a Boolean if it's divisible by 3 or not, but then we're actually going to index the list on the left with that result. If that Boolean returns true, it's going to coerce that into a 1 and then index the yes and then print that out. If it's false, it'll return 0, coerce that, it'll return false, coerce that into a 0, and then print out the no. Which means that this line just prints yes if a sum of numbers given in the input is divisible by 3. It can get worse than this. Here was another submission from last year. which is, I think, 8 if statements just stacked on top of one another. Now, it could be the case that there's a very succinct way to do this. I can't tell you what this does now. I may be able to last year, but I don't even know what the context is. But in some cases in these contests, it's faster to just copy and paste an if statement 8 times than to derive the general case or make some generic function to do it. You can just submit this file and never look at it again, unless you're talking about how bad it is. There's also a lot in the Python standard library that saves us a lot of boilerplate when we're writing our solutions. The collections library has default dict and deck, where you can access both sides of the list pretty easily. Editors has product, combinations, and permutations. And what this means is that we can repeat and reuse these functions in any solution that we use. We don't need to write up our own custom implementation that may be faulty and buggy, and it means that we can use them and immediately know that they're going to work to what we want. In the math library, we've got com, perm, TCD, and LCM. And the benefit with some of these ones as well is that they commonly use the C API, which makes it a lot faster than if we were to write a solution immediately in Python. Another library that we commonly use is the heap queue. So this is Python's implementation of a priority queue, where you can add items to a list and it'll maintain that list being sorted. You can then remove the minimum or maximum one pretty cheaply. Other libraries that we use include fraction and decimal for lossless float storage without having to worry about it being stored in binary, functools for caching, and then time and date time for time math. Now, the second thing that you can do with Python is having fast code. However, we looked at before that Python is slow. So the asterisk there is to kind of indicate that we may have to do some cheating. The first thing, or the naive approach, is just to make your code run faster. Some of you may remember the big O graph from maybe university. Being aware of Python's limitations from the input and being able to code a solution that matches that is important. If our input is, say, 1 million, we know that doing an n-squared solution wouldn't be able to complete under the time limit. So we may be required to do an n log n run or an O of n solution. If our input size is instead 1,000, n-squared may be doable. So being aware of the limitations that Python can do in the input and creating a solution that matches that before you even start coding will allow you to solve the problem more efficiently. Another way that you can do is to kind of benchmark the solution that you already have. If we have a problem that has 2 variables, maybe 1,000 and 100,000, what we can do is generate the worst case input, something like this, where we just generate 1,000 random numbers. We can then pass this worst case input into our function. If the time limit was 1 second and ours finishes in 1.2 or 1.3 seconds, we know that we're very close. So maybe removing a for loop or checking that we're doing something in the most efficient way could be a good solution. If it instead runs in 10 seconds, 100 seconds, or doesn't even finish, we may be on the complete wrong path and have to go back to the drawing board and make a new solution. One other thing that we can do is use Python to generate a solution for us. Here is a list of primes, specifically every prime up to 1 million. We had a problem last year where we had to find the nth prime. There were some other things involved, but that was the raw part of the problem. We created the most efficient solution that we knew of at the time, and it just wasn't finishing in the time limit for the problem. One solution that we ended up going with was to have some slow code to generate all the primes and write it to a file. We could then get this list of primes here and store it within our submission file. And then to get the nth prime, we can just index this list. Now, this would never work in any professional or industry code. It's got fixed input. We're only up to 1 million. If the input changes at any point, this wouldn't work anymore. But in the specific context of a programming contest, this is sometimes exactly what you need. And it would finish a lot faster than other solutions where you'd have to find the prime manually. Now, other solutions involve just kind of learning more about Python and what algorithms you can use. You're allowed to bring in printed materials to these contests. So there's specific competitive programming books that teach you algorithms that you may be able to use in any language. CP4 specifically, the one on the left, was very helpful in the New Zealand programming contest. You can also learn algorithms in other ways, Leak Code, HackerRank, university courses and whatnot. These will allow you to just be more aware of what you can do in any language. I'm also going to cover some Python tips for kind of 4 specific cases where the speed-ups aren't necessarily obvious, but there are ways that you can heavily optimize your code. With the first one, there's actually more of an error where we're multiplying a list by a number, and when you multiply a list like that, it copies the list in reference rather than the actual data, which means that if you modify an item in the list, it'll modify it for all the values. A correct option to do here would be to use a for loop, and that declares a new instance of the list for each time you iterate through. With the second one, we're using an if statement and we've got a number in it. Now, this might be thought of as a speed up. You don't have to type if the number is greater than 0 or if the number is equal to 0. However, in many cases, the behavior of this is inconsistent. I know that there have been at least 2 or 3 cases where we've had to refactor our code and we've introduced negative numbers into it. And then we spent an hour trying to find the bug because it turns out that the Boolean of a negative number is true. And that's not always necessarily obvious when you're just reading this quickly, especially in a time-pressured contest. So making it more declarative and specifying what the Boolean you're actually looking for is useful. The third case, we're inserting an item at the start of a list. This means that you have to move the whole list in memory in order to insert the first item. So using an alternative data structure, such as a deck, where you can append left without moving the whole list, or a set would be useful. The last one is very similar. We're checking if an item is in a list, and that's got to iterate through the whole list. So using a set or a dictionary would also be appropriate. I'm also going to touch on good code and moving from competitive programming to industry. If you were to submit this in your project, you'd probably get a comment from your coworker saying that it is bad. And that's true, because it is bad. And that's because in a professional kind of context, you just want the code to be readable and you're not really worried about it being fast. You want it to be fast. However, when you're that low level, there's a lot of premature optimization that can occur. And it's likely that a single HTTP request is 100 times slower than any optimization that you're going to make. This is the complete opposite to competitive programming, where you want your code to be fast, but you don't care about it being readable. There's also a lot of software engineering principles that you miss in these contests. Git, TS, all those other acronyms, you don't get to do them and really apply them properly. So you could make the argument that being good at competitive programming does not mean you're good at software engineering. However, you do learn different things. Teamwork and time management are the most important. But you've learned a lot of things about Python that you wouldn't normally learn otherwise. You'll learn about different algorithms and how to debug quickly. As well as that, you can also learn how to communicate via the code in an efficient way. If you're really focusing on solving a problem quickly, you'll start with maybe the worst solution that you can. Something like before when we had the 8 if statements. It may take you a short amount of time to create your first solution to the problem and submit it. But if it's wrong, you could spend half an hour to an hour debugging your messy 1-letter variable, short function, no comment code that you've made. However, if you spend some more time learning competitive programming and you're slightly more verbose and you really apply some of those engineering principles like knowing how to communicate, you might add a comment or two and you might create some functions instead of just having it all in main. Your first solution may be slower, but as you debug it, you'll overall be able to solve the problem quicker as you've made your code slightly more flexible. And then if you're moving into industry code, you want it to be the most efficient, readable, maintainable code. And therefore, it would take you a while to solve the problem. And now that cost overall is expected to kind of cancel out as more people read your code and add to it and add new things. But in the competitive programming thing, you're not really worried about that. So that creates a graph kind of like this. Now, the idea is that as you learn in competitive programming, and you learn how to make your code better to submit the problems faster, you can apply those skills to industry. So something like this. So whether being good at software engineering is the same, whether being good at competitive programming is the same as being good at software engineering is kind of up to you. Now, what's next in the context of competitive programming? Well, there's the kind of international context next week, where students across all of New Zealand compete to go to regionals in Sydney for this year. There's contests like the Canterbury Schools Programming Contest, the New Zealand Programming Contest, and the Programming Contest for Girls that are competed nationally. Last year, the Programming Contest for Girls had 42 Year 10 students across the country, which is amazing to see. You've got university courses and university coding competitions that allow people to compete and kind of improve their own skills. And then you also just kind of meet new people and learn new things. And whether you or your kids are nearing university, there's a whole bunch of opportunities that you can do throughout high school and tertiary education that allow you to learn all of these things. Thanks.
Thank you, Cameron. The floor is now open for questions.
So in these programming competitions with multiple teammates, you've got 3 people, 1 laptop, 2 hands is plenty for writing codes. What is like a good way of organizing your team around solving these questions so that, one person isn't doing all the work?
Yeah, so that's a good question. Commonly in these contests, you get given 8 to 10 problems. What we'll commonly do is split up the problems between us, and then we'll individually, with pen and paper, like author a solution or draw the data structure that we'd need to solve it. Another option would be to have a little bit of peer programming. Someone will write up the solution, and then you'll have someone writing directly over their shoulder, making sure they're doing anything correctly. And it's quite confronting to code in that way, but you're allowed to spot errors a lot quicker than you would otherwise.
When you say that there's a time limit, that is sort of got to be hardware dependent. So is that like it's 10 seconds on the machine that we're going to run it on, or on the however they do it?
Yep. So these contests are all run on a contest server. So when you upload your submission, they get put to the server that's kind of running all of them. That's been run probably in Australia or somewhere, and then that runs all of the solutions and probably a Dockerized container on the same hardware with the same memory constraints. It's allocated such that the timing's consistent, and the problem limits are chosen in such a way where if you had an extra kind of for loop or two, it won't really do too much. But if you were using the complete wrong algorithm, then it'll be way over the time limit. They're kind of written such that there's no real, just over the edge cases like that.
With the pending removal of the global interpreter lock, do you think that'll make Python more competitive in this kind of environment, or would you be limited down to just using a standard implementation?
I'm not fully sure about that one. Yeah, I think it really depends on the speed up that removing the GIL would offer to Python. At the end of the day, it's still being compiled into C, so there's a chance that there'll be some overhead there that's not been offered, or is it not? Yeah, but I don't know. It's hard to see at the moment what the speed up is like, so I wouldn't be able to say.
I was doing competitive programming at University of Canterbury a long time ago now. Is Richard Lobb still involved?
Richard Lobb is still very involved.
Nice.
Yeah.
I was just going to say to the other question, I think it's quite rare actually to use multi-threading in these problems. Usually it's a constant time speed up rather than an algorithmic speed up.
Yeah, commonly I think with using multi-threading, the cost of maybe spinning it up or splitting up the data is such that it's a lot more expensive than the benefits that you'd get from multi-threading.
This is more just for everyone here. How many people have been involved in programming competitions here?
So how long have you been using Python in these competitions for?
I've done programming contests since 2021, and I've used Python for all of them.
Would you ever choose the language based on the problem, or just always Python? Or do any other teams do that?
A lot of teams, they do switch depending on, they'll start with Python for the easy ones so they can get the solutions in fast, and then switch to maybe C++ or Java for the more harder ones where you need that speed up. For our team personally, I feel like there's a lot of overhead that's needed with C++ to really understand what's offered in the standard libraries, and we're quite proficient at Python, and so for us at the moment, it's kind of the easiest way to do things.
I was just wondering kind of what experience you had with, I guess, certain data structures that aren't necessarily part of the Python standard library, and kind of implementing things like I guess, segment trees or whatever in Python, how you kind of find that experience if you even use them, I guess.
For what data structure, sorry?
Segment trees.
Segment trees. Yeah, I haven't had any personal experience implementing seg trees. I know that I think my teammates have. But a lot of the times you would code up these data structures, for almost every competition. And so you kind of get into the habit and you kind of memorize the maybe template that you need, and then you really adjust it based on the constraints of the problem.
Did you say you were limited to languages you could use, or could you take Mojo sort of to take Python-esque type code and compile it down?
You have to upload a file that is one of, I think, 6 languages.
Okay, right.
Yeah.
So did you say they're using PyPy on the submission servers now? Do you know the difference in speed between the between CPython and PyPy?
Off the top of my head, I think PyPy is, on average, maybe 3 times faster. But I think it depends on the context for a lot of cases as to what exactly you're doing.
I would just like to add that there's also an open section for like the New Zealand programming contest that was last week. So you can go as an open and go and code and do the competitive. It's quite fun.
Yeah, I have one question too. So yes, there is seems to be a lot of difference between us programming in a professional environment and competitive programming. How does it apply to debugging? Is there a difference in debugging as well?
So like debugging versus competitive programming.
Debugging, because the code is so tightly written. Can debugging be more challenging in competitive programming compared to debugging a elaborate code?
Yeah, when you're debugging these competitive programming submissions, you kind of have an idea of maybe where the error may be. You'd really be going kind of section by section and kind of figuring out. When you kind of can visualize the data structures, it can be easy to kind of log at each point and see where it's inconsistent with how you're visualizing it. Commonly in a professional environment, you're not really dealing with data structures and algorithms as much, whether you're dealing with web or kind of back-end stuff. You'll be debugging it in a different context. You'll be taking in some kind of network requests or some things like that. And it's different from debugging data structures.